Hello students. In this video we're going to talk about accuracy versus precision. Accuracy is how close a measurement is to the true value, or how right you are, whereas precision is how close measurements are to each other, and this is indicative of what we call reproducibility. So let's look at three cases so that we can differentiate accuracy and precision. So in the first case, let's say this red represents my target value, and I take three measurements, and so I hit that target every time. With each measurement I'm hitting the target value. I am said to have good accuracy and good precision. In this case, I'm hitting the target value, that's the accuracy. The precision is I'm getting reproducibility. I'm getting that same repetitive measurement. In the second case, we're not hitting our target value, yet we're getting reproducibility, we're getting repetitive measurements. Okay? So we are said to have poor accuracy and good precision. Whenever you have a case like this, leads to something called systematic errors. And these are typically caused by the instrument in which you're using. This is not necessarily a bad thing, because if it's caused by the instrument that we're using, we can calibrate the instrument, and that would thus eliminate the systematic errors that we are experiencing. In the third case, what we have is we're taking our measurements and we're all over the place. There is no accuracy because we're not hitting a target value, and there is no precision because we don't have any reproducibility in the measurements in which we're making. And this leads us down the road to something called random errors, also called indeterminate errors. So we have poor accuracy and we have poor precision. Random errors are caused by the experimenter, the one that is taking the measurements. Okay, it's not the instrumentation in this case. It is the one that is taking the measurements. And what this could be a result of sloppy technique, not following the procedure correctly, what have you. So how do we measure accuracy? Well, we use percent error as a means of doing that, and percent error indicates the accuracy in a measurement. Percent error is equal to the absolute value of the theoretical value minus the experimental value divided by the theoretical value times 100. Notice I said absolute value. Alright? So that means that, let's say our experimental value was larger than our theoretical value. So if you was to take the difference between the two, you would get a negative number, right? Well, what absolute value does for us is it says, okay, if you get a negative number, just drop the negative sign. It will always be positive. Okay? So when you take the difference, if it's negative, you just drop the negative sign, because your percent error is always going to be a positive value. You're not going to get a negative percent error. Okay? So remember that. Alright, so theoretical value is also known as actual value, or known value, or true value. So these terms roughly mean the same thing as theoretical value. So if you see this equation, and it might say actual value minus experimental value divided by actual value, it means the same thing as theoretical value. Okay? Okay, so let's say we have a lab task where we're to take the temperature reading of 3 different beakers containing ice water. It has a true value of 0 degrees Celsius. So let's say in the first lab group, they get 3 different temperature readings for each beaker of ice water. What does it mean, and what would the group need to do to get the true value? Let's say in the second lab group, they get the same temperature reading for each beaker of ice water, but not the true value. What does it mean, and what would the group need to do to get the true value? Ponder that, as I will perhaps be asking a discussion question similar to this. And so, as always, I hope this video was helpful to you, and happy studies.